A triangle and an incomplete proof are shown. The given information is that angle B is congruent to angle C, and AD is an altitude of triangle ABC. We are going to try to prove that this is an isosceles triangle. So if we take a look at this proof, this one is considered one of those flow proofs, and so we want to follow our arrows and we want to think about how we can get from one side to the other. If these are challenging, you can write this out on your scratch paper and make it into a 2-column proof. It's still the same concepts, it's just that this is a different way of writing it out. But what we want to do is just kind of start over here. AD is an altitude of triangle ABC. That's just the given information. So we know that this is an altitude. If it is an altitude, we do know that the measures of ADC would be 90 degrees and ADB is 90 degrees as well. When it's an altitude, it creates 90 degrees here around D. So what we want to think about next is we're really talking about AD. Since we have an arrow coming out of this, we know that we need something that's going to have to do with AD. If we look at our possible choices, we can't prove our triangles are congruent using SAS, AAS, or any of that yet. If we don't have congruent triangles yet, we can't use CPCTC. So we really can only use one of these two in order to go in here. AD is congruent to AB. Well, we definitely don't know that for sure. It doesn't look like it even is. But we could say that AD is congruent to AD. Since we have AD as a bisector, it's really creating two triangles here, one on the right and one on the left. This side is used for both. So that will probably go there, and our reasoning is because that is the reflexive property. So if we want to go ahead and mark this up here, we would know that this is congruent to itself. We also know we have two 90-degree angles. So as we go into here, since they are equal, they're going to be congruent for the 90-degree angles. If we take a look at this, we're also given that angle B is congruent to angle C, which is marked up here as well. So now we can say that our triangles are congruent, looking at our smaller ones, ACD and ABD. When we think of our reasoning, and I must have scrolled up a little bit, but it's either SAS, AAS, side, 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 or HL. Here we have AAS because that's the order in which those are given. So we would go ahead and choose AAS and just drag and drop it into that location. Now that we have our congruent triangles, we know that AC is going to be congruent to AB, and that is because since we know that these triangles are congruent, our corresponding parts of congruent triangles are congruent. So the CPCTC is what that stands for. Now, since we have the congruent sides, we know that by the definition of an isosceles triangle, this is ABC is isosceles, and therefore this would be the correct proof. So some things to keep in mind. It's been a while since we've seen flow proofs, but you just start from one thing. You follow the arrows, and you want to make sure that it does make sense in the order that's given. If it helps to make that as a 2-column proof, you definitely can, so that it can help you out some. If you have any questions, please let me know.